In this video, we're going to talk about polynomial functions. A polynomial function is defined by f of x plus a0 plus a1 x1 plus a2 x squared plus all the way up to an x to the nth power. Another way of describing a polynomial function is a bunch of additions of power functions. Power functions are defined by a times x to the k, and a couple of examples I'm going to go and put right here. If we combine these, we get a polynomial function as seen above. This a to the 0, a1, a2, and an, those are just notation for any constant number. So this could be 1 in this case, 5 in this case, and 1/3 in this case. And this is the same x to the 1, x to the 2, all the way up to x to the n. Now I'm going to go ahead and put some properties of power functions and polynomial functions over here on the right. Okay, so the first property we're going to look at is if the highest power in a polynomial function, so in this top case, this x to the n, is even, or in a power function that you only have one copy of this, so if this power right here, k, is even, then both ends, the left and the right, trend in the same direction. And they trend in the opposite direction if the highest power is odd. So here I kind of drew a couple of examples, y equals x squared, which clearly has an even power, and these left and right sides both trend upwards, whereas here we have an odd power and the left side trends downwards, whereas the right side trends upwards. And the second property that kind of follows from this first one states that if the leading coefficient of the highest power is positive, then the right side will trend upwards and vice versa. So here we have a positive 1 as our coefficient of y equals x squared. This positive 1 is implied right here, which means that the right side is going to trend up, but because this power is even, the right and the left sides trend in the same direction, so the left side also trends up. Let's look at a couple of examples of this property right up here. Okay, so here we have two examples of this property. We can use this first example and see that the right side of the graph trends upwards because the coefficient here, again, is this implied positive 1. But because the highest power is odd, the right side and the left side trend in opposite directions, which means the left side here trends downwards. If we take the second, more general example, which is a 4th degree polynomial, that just means a polynomial that highest power is 4. We know that because this is an even power as the highest power, the left and the right sides are going to trend in the same direction. And because the graph here shows that both sides point downwards, or more specifically the right side points downwards, that this a4 coefficient right here is going to have to be negative. Like I said, that's because this right side here points downwards by this part of our property right here. Okay, so before we finish this video off, I just want to point out a couple of terms that I've been using, leading coefficient and degree. So the leading coefficient is when you put the polynomial function in descending order of power. So n is the greatest power, and then it goes downwards from there. So x2 finishing with x and x to the 0 power, which is 1. The leading coefficient is this an term right here. This is in fact the leading coefficient of this polynomial. So if you get a problem from your professor or teacher that says, find the leading coefficient of the polynomial, this an is what you're going to want to look for. Whatever is attached to the highest degree of x. And when we say the degree of a polynomial, we're just talking about this n right here. Whatever the highest degree is in the polynomial, that is the degree of the entire function. Okay, that's enough for now.